I have your please. Ladies and gentlemen, this panel session is about today. The Honorable Rector University of Madura, the Honorable Vice Rectors, University of Madura, all deans, University of Madura, the Honorable Head of Research on Community Supervision Institute, respectable guest speakers, and distinguished participants, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. It is indeed a pleasure and honor to welcome you in this international conference on engineering, science, and technology in Grand Gabang Hotel, Surabaya, one of the most beautiful city in East Java, Indonesia. First of all, allow me to greet and welcome you all, because today we have hybrid one. I also want to welcome for the virtual participants. I want to say good morning from Surabaya. Also, I say good morning for all participants in person here. I am Surono, the moderator of this panel sessions. Science and technology, of course. And today, of course, we have a list of remarkable speakers from abroad and from Indonesia. But before we start talk about this discussion panel, I would like to welcome also from the distinguished presenters, Ms. Wahyu Ramadhan, PhD. Are you with us? Hello? Ms. Wahyu Ramadhan, are you with us? Because right now she is joining in virtual. Good morning. Ms. Wahyu Ramadhan, I can see you on screens. Good morning. Ms. Wahyu Rahmaina, PhD. Okay, and next we also have a remarkable presenter from Australia, Professor Boy Camps. How are you, Professor? Good morning from Surabaya. Can you hear my voice? Hello? Are you with us, Professor Boycam from Australia? Okay, while we are waiting for having the connection, I also introduce the presenter who is sitting beside to me. She is Ms. Andarini Dwi Cahyani, PhD. She is from Universitas Trunojoyo, Madura. Well, ladies and gentlemen, before we start the panel session, I would like to inform you how this panel session is conducted. First, of course, we will invite for the three speakers to present their material in turns. I mean, they will present the material one by one, and then they will make turns. And the presentation will last about 20 minutes, and after that, the next session is about question and answer. Well, but before we start, I will try to repeat my connection with Ms. Wahyu Rahmaidar, PhD from Tokyo. Good morning. Miss Wahyu Romain PST. Hello? Good morning, Miss Wahyu PST. Can you hear my voice? Hello? Good morning. Okay, I will try to greet Professor Roy Kans. Can you hear my voice, Professor?
Yes, now I can hear. Can you see me? Can you hear me?
Okay, thank you.
Yeah,
Okay.
now only I can hear. I can't hear whatever you have been saying. Sorry.
Okay. So sorry because perhaps some connection. But before we start this conversation, I try to reconnect with Miss Wahyu Romai Rahmaniar, PSG from Tokyo. Good morning, Miss Wahyu Rahmaniar. Hello, can you hear my voice?
Hello?
Hello?
Yes. Yes, I can hear your voice, but it's echoed. Echoed. Can you check your microphone?
Okay, thank you. Okay. Okay, I'm so sorry because perhaps technical matters, but I try to repeat about this conversation. I will try to re-explain that this conversation we conducted first will be presentation from the speakers, and we started Ms. Wahyu Rahmani PSC from Tokyo, and then next turns will be Professor by Khan from Australia, and the last will be Mrs. Anggarini Dwi Cahyani from Indonesia. And the presentation will be last about 20 minutes. And then the next session will be question and answer from the participant. We are kindly lettered invite questions and comments during our presentations. Okay, ladies and gentlemen, to introduce our speakers, I will try to invite our first speaker. She is Miss Wahyu Rahman PhD. But before we start the voice presentation, I think it is necessary for me to introduce her briefly about her curriculum vitae. Uh, Ms. Rahman PhD is an assistant professor in the Institute of Mathematics in Tokyo Institute of Technology, Japan. She obtained bachelor in Madura University, while master and PhD was obtained in National Central University in Taiwan. She also has strong interest in specific topics like artificial intelligence, medical imaging, and computer vision. She has also transitioned research from 2010 until now, and software and hardware skills is obtained from intermediate to advanced. Many publications are published in international journals, and is also active in academic society and many universities. And for today, I think Ms. Wahyu Rahmania, PhD, will present about artificial intelligence. I think it is a very interesting topic to listen and to discuss better. Now, I will repeat to greet Ms. Wahyu Rahman PhD. Ms. Wahyu Rahmania. Okay, are you with us right now?
Yes.
Okay.
Now,
Without further ado, allow me to welcome the speaker, Wahyu Rahman PhD, to make her presentation.
okay,
Thanks,
thanks,
Ms.
Ms.
Wahyu Rahman PhD.
Okay. I share my screen or I already sent my PPT.
Yeah, yes, screen. You can send your PPT.
I mean, I already sent my PPT to
Okay.
committee. Wait a minute, because I save my PPT in my tablets. Wait a minute.
Okay, what do you want? Okay. Can you see the screen right now?
Yes.
Yes. Okay. Time is yours right now. It's what you want to guess.
I mean, this is. Can you make it a presentation slide? I mean, the F5.
Yes.
It's still PPT slide. Presentation mode. It's your screen, right?
Yes. It's my screen.
Yeah, please make it presentation mode, not PowerPoint. F5, yes, yes. Okay. Good afternoon, everyone. Thank you for joining the first Trunojoyo Madura International Conference 2023. My name is Wahyu Rahmaniar. I'm an assistant professor, specially appointed from Tokyo Institute of Technology in Japan. Today I will present artificial intelligence or AI in medical image. Okay, next. This is my content. First, I will introduce some about basic medical image, and then I will share about my research in medical image assisting device, and maybe we can have Q&A. Next. Next. Okay, next. The first medical imaging is also known as radiology. Uh, Wait a minute, there's someone in my door. Sorry, I got a package. Okay, medical image is also known as radiology in fields of medicine. And then the procedure, it can be a kind of non-invasive test because we can get the modern medicine. So the medical imaging can be X-ray, MRI, ultrasound, endoscope, or CT scans. And it can be 2D or 3D. For 3D, it can have three sides like sagittal plane, coronal plane, and transverse plane. We call it as volumetrics. Next. For example, medical imaging for like for brain imaging for X-ray, MRI, MRA, CT, and PET scan, it will show different results. It depends on how doctor needs the image to analyze the disease. Next. And for assistive device, it's something to help someone with limited motoric or some limitation in their like vision, hearing, communication, and others. Next. For example, AI in medical imaging, it can be fractures detection. Usually it uses X-ray. It can be tumor detection, usually using CT scan or MRI. Next. It also can be cancer detection. It can be like breast cancer, lung, or for another disease like skin. Or next. AI in assistive device can help for visually impaired, physical disability, speech impaired, or hearing impaired. So, for this technology, we can use it using image or sound or like another assistive device to help people with uh, disability. Next. I will show my previous results in medical image. First is about calcaneal fractures. It to show the segmentation and classification of calcaneal fractures in CT image. It already published in 2019 in Applied Science Journal. Next. The contribution is not so many paper do these things for calcaneal or for foot bone fracture because we it's a bit difficult because the bone in our foot is kind of solid and it's difficult to determine the fractures and also to get the image is not so many open source that share this kind of image and then but for this research, I used three anatomical planar views, coronal transfer, and sagittal to show the segmentation. First, we do basic pre-processing like median filters to make the image smoother and then less noisy. And then I did foreground detection like feature detection, then classification, then we can get the anatomical plane orientation. The idea is so doctor can put any kind of planar view and this algorithm can automatically choose the what kind of this planar view. And then we do foreground selection. I do some basic step for image processing like segmentation, also segmentation is to get the automatic black and white image, but with the base threshold to determine which part will be black pixel and which part will be white pixel. Then after we got the black and white image, we try contour detection to get the bones, the calcaneus bone. Then we selected the fracture part. Then after we got the part, we segmented the fracture part. Then we analyze to determine the classification. Next. For the feature extraction, I use a machine learning. This is local binary pattern. For the local binary pattern, the idea is we can learn the local histogram and then global histogram, so we can learn the feature from the CT scan better. Next. And then after we got the features, the global histogram features, then we classify these features. We training the image which uh, classified as transfer and sagittal is to select the planar views. We use the AdaBoost algorithm. Then with this kind of AdaBoost algorithm, we can determine the maximize margin between positive and negative samples. So we can get the best features to determine the planar views. For the example, this is the image of transverse, coronal, and sagittal. And after we got the planar views, we crop the on the calcaneal part. Next. After we got the calcaneal part, we do the segmentation. We use the OSU method, then morphological operation, then we fragment the segmentation with the contour detection, and then we segment it with different colors so doctor can see the difference of the part of the fracture part, then we can classify it. For this classification, uh, we determine it as type 1, type 2, type 3, and type 4. For type 1, which means it's only almost no fracture, but there's some line fractures, so the bone is not broken, but a bit broken, not separated. So type 2 is means there are two fractures, then type 3 there are three fractures, and type 4 means more than three fractures. And this is for coronal and transfer view, but for sagittal view, the bone is looks a bit different. So and it a bit difficult than coronal and transfer view. So we add contrast enhancement in the sagittal view to make the bones easier to segment it. Next. And in sagittal view, we determine it as line fracture and type A, type B, and type C. For example, if we have line fractures, first we divided the sagittal view calcaneal parts into three same uh, three same area in the image. So we can have left, middle, and right area. For example, if we have a mostly line fracture in the center area, we determine it as B, as type B. And then if we have the fragment fractures, we determine where these fragment fractures meet in the image. So if these two kind of fragments meet in the center of image, we determine it as type B. If it's only on the left side, it's type A, and if it is on the right side, it's type C. And if we have like we segmented uh, small fractures in the big fractures, so we only selected the big fragments to determine the type of the fractures. Next. And then the result, if we got the normal calcaneus, so the segmentation will be full and solid. But if we get the type 1 or line fracture, the segmentation won't be solid. And then type 2 will be 2 fragments, type 3 will be 3 fragments, and type 4 will be more than 3 fragments. And in the sagittal image, it looks like this for type A, type B, and type C. So for this result is quite good for the precision rates and then also for the processing time. Next. For my next result is about scoliosis, automated cup-ankle measurement on vertebrae detection for assessment of spinal curvature deformity. Cup-ankle is the ankle of the scoliosis. Vertebra is the spine. It's a slice of the spines. So for this research, I determined 17 vertebrae. It's already published in IEEE Transaction on Biomedical Engineering this year. Next. So this is the step. First, we have input image X-ray, and then we segmented the spine area. Then we determine its vertebrae detection, vertebrae area is slice, 17 slice, and then we determine where is the apex. Apex is the most tilted vertebrae, the most deepest curve of the vertebrae. So after we got the apex, we determine the most tilted vertebrae upper and lower of the uh, apex, and we mm, we make a line. So we calculate the angle of the intersection of these two lines. Then this is using convolutional neural networks, and then we determine it as C shape, S shape type 1, and S shape type 2, and then Copenhagen determined as normal, mild, moderate, or severe. Next. And this is the networks. First, after we segmented the image, we determine for this segmented spine which part is the vertebrae. Each slice of the vertebrae should be accurate. So we determine, we training for each area. So the vertebrae actually is kind of the rectangle. So for rectangle, we can have four corners and then one center. So our data set contain of uh, 4 times 17 of each vertebrae. So we can have uh, we training each of the corner area of the vertebrae and then each center area of the vertebrae. Then uh, we use our glass networks and then determine the local and global information to get it as correct as possible. And then after that, we got the prediction of the location of 5 coordinates for each vertebrae, include 4 corners and 1 center. Then we calculate the corresponding vectors. Then we group for each into area. Next. This is the example after we got the 17 vertebrae from the lower part of the neck. It's called T1 until the our uh, back. It's called sacral or sacrum. So T1 to T12 is called thoracic, and then L1 to L5 is called lumbar. So for the spinal curvature, there are two classifications here, King and Moy, and then Lenke. For the apex, there are three kinds of apex, PT, MT, and TL. PT means apex if the apex is on the area of T2 to T5. MT means if the apex is found on the area T6 to T11. And then TL means if the apex is on the T12 to L5. Then if we only found uh, two apex on PTMT, we call it as S-shape type 1. And if we find its three kinds of apex in PTL, we call it as S-shape type 2. Then if there's only one apex, it's called C-shape. And for the Lenke classification, we determine first the L5 or CSVL, center of the sacrum. So if we get the L5, we determine the center of L5. Then we draw the line. Then we determine this line between the L1 to L4. If this line is in the between or ALV between L1 to L4, it's mean type A. If it's this line is touch the edge of the ALV, is mean type B, and if it does not connect to ALV, is mean type C. And after that, we calculate the cove angle. If we found the apex, we calculate the cove angle. And if it's more than 10, between 10 to 25, is mean the classification is mild. If it's 25 to 40 is mean moderate, and if it's more than 40 is mean severe. Next. And this is the result. So for results, we draw each area of the vertebrae, then we make a label T1 to L5, and then we classify the apex as PT, MT, or TL, and then classify the shape, C shape, S shape 1, or S shape 2. And this for this method is quite accurate. So we draw it like so it can help doctors to calculate the cup ankle automatic, and then also doctor can check its area of the of vertebra T1 to L5. So also doctors usually nowadays still calculate the cup ankle manually, and for different doctor maybe they can have a different measurement because they do it manually, because just a bit pixel when we get the apex a bit different pixel, and when we draw the line and we find intersection calculate the angle, each doctor may have like 5 degrees differences in the measurement. So this AI idea is to make the measurements is accurate for each doctor, and it will be very helpful to make a decision quite fast for the treatment of the patient. Okay, next. Next.
Sorry, just a moment.
Next. Hello.
Yes, just a moment as well.
Oh, next I will present about my previous results in the assistive device is to control the cursor and orientation using the head. It's to help people with disability with limited motor skills or paralyzed, like they cannot move their body, so they can only move their head. And for people that doesn't have finger or doesn't have arms, so they can use their head to control the cursors. Next. For this research is already published in IEEE Transaction on Neural System and Rehabilitation. And this is the method. First, we got the input image, and then we do the face detection, then eye landmark detection, and then head pose. From the face, we determine the head pose. Then from the head pose and the face location, we determine the trajectory, XY trajectory for the cursor control. Then smooth the line so the movement will be smooth using Kalman filter. And it can be used to move the mouse up and down, left and right. Also click the mouse button using the head, like bending the head to left or right. And also it can be used because it's already 3 degrees of freedom. It can be used also to control robot or joystick for the purpose. Next. For face detection here, I use yellow fever. Then after we got the image, we crop on the face area. And then after we got the face area, we determine the landmarks on our face. But we only choose 3 kind of landmarks on the eyes, in the center, and then left and right are eyes. This eye landmark is to determine whether the user is move or not, because maybe the user doesn't mean to move, but but because the head pose will always calculate, so it's to avoid the wrong calculation. Next. For the head pose estimation, CNN with the backbone ResNet 101 with the fine grained structure, we learned the uh, face. We have some data sets that already have information about the face position and its relation with the pose estimation in X, Y, and Z Yao Petrol. something like that. And then with this kind of network, we got the expectation of yaw, pitch, and roll to determine the head pose x and y x and y location of the cursor. Next. Then after we got the head pose, yaw, pitch, and roll, and we combine this information with the position of the face face bounding box in the image. Then we calculate it to get the trajectory x and y of the cursor. Then we smooth the trajectory with Kalman filter. This is the example of the UI control. So we use the UI to check the accuracy of our method. Then the user can use this UI to learn how they move this cursor or joystick. And then it has some instruction like if first we move from the first box, second box, third box, and so on. And then for each box, it has a command for left click, right click, and so on. And this, we only need a camera in front of the PC or laptop. So it's wireless. Next. And then this example. Can you play the video?
Okay.
Yes. So the user just sit in front of the desktop and then move their head like this, and then they can control the cursor. Okay. Can you? Oh, sorry. Next. I think it's all. Next. Okay, I think that's all from me. That's my presentation. Thank you for listening. If you have question, you can ask me.
Okay, thank you very much for Ms. Wahyu Rahmadiar, PhD, for informative and interesting presentations. For the audience, please you give applause for her presentation. As we know that her presentations inform us how artificial intelligence help us, particularly in medical medicine. It's very benefit for us how artificial intelligence is very useful in our lives. But because the post presentation is very interesting, and I have to hope that the in-person participants and also virtual participants to be patient to deliver questions because we have to watch the next presentations that will be conducted by Professor Boy Kang from Australia. I think he also one remarkable speaker today because Professor Boy Kang is expert in uh, subtribes, logistic, and so on. And I think today he will present for his important expertise. But before, I want to greet again Professor Boyka. I used to be Professor Boy.
Yes, I can hear you.
Okay, thank you. Today, before we start the presentation from Professor Baikams, I would like to inform you about a brief his activity, and uh, I think there will be kinds of screen for you about his curriculum vitae. Uh, Today, we have a repeating speaker, Professor Baikam. He is a professor in School of Accounting, Information System and Supply Chain, College of Business and Law, MIT, Royal Melbourne Institute, University, Australia. And he holds a PhD from University of California, Los Angeles. He also sits on the editorial editor reports of International Journals of Logistics, Management and Logistics. He also the co-author of monumental book sightings entitled Consumer Logistics 2018 and Configured by Consumption 2022. He has strong research records in the area of supply chain logistics, digital supply chains, and scholarship teaching and learning. He also received 2 accolades, including 2 Australian Networks Awards, an Australian Research Council, LinkedIn Grant, and an Australia Transport Safety Bureau Research Award. And Purboy is also regularly invited to give public lectures and teach in China, England, France, Indonesia, Korea, Taiwan. Of course, numerous selected articles are published in reputable international journals. So to mention, so his article, I think a lot of articles was published in reputable international journals. And the last one, I think Professor Boy Camps are also principal investigators for harvesting Hope's renewable energy, clean water, and quality soil for Madura saltwater community through seaweed farming. And it is connecting environments and climate change collaboration research. He is also principal investigator, maritime supply chain security in the Indo-Pacific region, trade and policy implications for Australia Defence Department of Defence. That was a sort of brief CV from Professor Baikams, and now, with the times, let me allow to welcome Professor Baikam to present his presentation, and I think today he also present an interesting topic. And right now, Professor Baikam, we try to help you to share the screen for your presentation.
If you can share the slides, that would be good, because
Okay.
I think my internet is, or rather, I find it difficult to manipulate this Zoom or not use the Zoom.
Okay. Okay, just a moment, Professor. We are trying to share the screen. Okay, Professor Boy,
Yeah,
you see
I can see.
Okay, thank you. You can start right now. Time is yours.
Okay. Thank you, Pak Sriyono. Terima kasih. And first, before I start, may I also thank the organizing committee of this conference for giving me the opportunity to present a keynote address here. When you show my CV on screen, I didn't expect that. I have to say I'm extremely humbled by what you did. I thought you would just tell them who I am, that's all. Basically. So nonetheless, thank you very much for that kind introductions. Now, can you go move to the next slide, please? Because I have to present, just like the previous speaker, Dr. Wayu, I have to present away from the conference venue here back in Melbourne, I'd like to take 30 seconds to do an acknowledgement of the people of Wiwurrung and Bunurong language groups of the Eastern Kunai Nations, on whose unceded land we conduct the business of the university, that is MIT. So at MIT University, we respectfully acknowledge the ancestors and elders past and present. We also acknowledge the traditional custodians and their ancestors of the lands and water across Australia where we conduct our business. As I say, I'm very humbled by the fact that you actually flashed my brief CV on screen, but I prepared these slides here not so much as trying to emphasize what you have said or extend what you have said, but just to tell everybody, if you want to know more about me, about my writing, perhaps the best thing is to check out the two books that I have co-authored with a very prominent author, Professor Peter J. Remmer from Australian National Universities. Next slide, please. So, in line with the theme of your conference, which is undergirded by the aspirations of Society 5.0, I've chosen to present this topic, which I call When Human Meets Machine, an Industry 5.0 Perspective. Why do I do that? It is because under Industries 5.0, as what the European Union has provided here, you can see the code on my screen. It says that Industry 5.0 provides a vision of industries that aims to go beyond efficiency and productivity as their sole objective, because that's typically so-called what the various waves of industrializations has hoped to achieve. But in this particular case, what they want to emphasize is to reinforce the role and contributions of industry to society. So as far as Society 5.0 is concerned, this is a vision of how the future society should be, guided by scientific and technological innovations to create a human-centered, smart and lean society. And you have already got a glimpse of what that means from the previous speaker, Dr. Wayo, which I'm very, very impressed by the various things that she and her colleagues has been able to achieve. Well done, Dr. Wayo. Thank you for contributing to this humanity. Next slide, please. So to enable us to understand why we want to explore Industry 5.0, let me just take you back a little bit in time in terms of how that 5 waves of industries has evolved. So Industry 1.0, right, as they call it, started off in the late 1700s with the discovery of, or with the invention of the first mechanical loom. And that lasted for about 86 years until the first assembly line came off, and they called that period Industry 1.0. And from then on, there has been what we call incremental changes in terms of technology, and of course the complexities of the invention increases until somewhere in 1969 when this Industry 3.0, as they call it, emerges with automated production system, among many other things. And this is very much driven by the first programmable logic controller. From 1969 till 2011 is only a period of 42 years, and suddenly we saw that the next wave of industrializations have come on board. And that's very much characterized by what we have been enjoying in the last few years, like IoT, Internet of Things, robotics, AI, big data, cloud computing, very much encapsulated in what we call the cyber-physical systems. I believe this will be equivalent to what Dr. Wayu has been showing us, right? That kind of inventions and that kind of achievements. But we didn't expect, within even a shorter period in the last 9 years or so, or within a period of 9 years or so, we again kind of experience another wave of industrialization changes. And this is what they now call Industrial 5.0, characterized by what very much we call human-robot co-working. And that is why I choose to discuss on this topic about human meeting machines. How do they cooperate? How do they work together? And what role does these corporations play? How would that affect our lives? This is what we want to so-called hopefully harness for Society 5.0. So just let me quickly point out the role of machines in terms of the 5 waves of development. In industrializations or Industry 5.0, as they first started with the mechanical boom, at that stage, the role of the machine is very much like what I would call a power tool. It's basically helping humans to be more efficient, to increase their productivity, to harness the power of machines. But as it evolves into the second industrialization era, Industry 2.0, with the advent of the assembly line, divisions of labor, mass productions that has been made possible as a result, we call that specialized resource. So the role of machines is playing the role of a resource, and that is very specialized because they focus on specific sets of activities. And when Industry 3.0 emerged, and that's where automations came in. And I call that, or I summarize that in terms of what the machine is contributing to as automated capability. Now, as we move on to Industry 4.0, that role has made a quantum leap in a sense. That's why I look at it and I say the technological change is no longer evolutionary, nor incremental, or transformational. It is disruptive. Now, as we move on to Industry 5.0, the things that we are experiencing today, the things that we are seeing today, the change, I would characterize that as obstreperous, meaning it's beyond disruptive. It's highly chaotic, perhaps. And why? Because the role of machine, as I see it, has moved from being smart and competent to what I would refer to as domineering intelligence. Next slide, please. Why is it so? So let us just look at the differences. Let's explain that by looking at the differences between what we call artificial intelligence and human intelligence. What you can see here are 7 distinct, or rather distinct differences between the 2 sets of intelligence, right, which I call artificiality versus humanity. Artificial intelligence, in terms of decision makings, are very structured. Demonstrated again, right, by what you have seen in Dr. Wayo's presentation. Also demonstrated by a lot of the things that we do here in the supply chain and logistics area, in the sense that if we program a forklift to move from one part of the warehouse to another part, picking up goods along the way, and that forklift will only do that as prescribed. Human intelligence, the decisions could be unstructured. We move from one thing to another very quickly, depending on the context. So, as a result, in terms of artificial intelligence, they essentially are able to deal with what is called situations with high level of certainties. When it comes to situations with high level of uncertainties, we still rely on human intelligence. In that sense, repetitive routines would be best suited for artificial intelligence to play a very efficient and effective role. But it will be less effective when it comes to non-routine or non-repetitive tasks. As a matter of fact, I've just been talking to some of my colleagues in the industries in the last 2 days. We are having here what we call Black Friday sales in Australia or here. And he was telling me in his warehouse, all automated processes that have been put in place to deal with this so-called sudden surge in volume of purchases don't quite work because, right, the process has gone beyond predictions. So as a result, they have to dismantle, right, many of their processes and got to rely on human power. They got to recruit more part-time, more what you call sessional workers to come in to help out with the process with minimum automations. So this is what is happening in that context in the case of supply chain automations in a case that I know. All right. So between artificial and human intelligence, right? What we can say is artificial intelligence is about knowledge, characterized by what you already know from, right, these very recent phenomenal inventions called ChatGPT. In human intelligence, it's all about wisdom. And maybe I will share with you, right? I will share with you a little story that I pick up from my granddaughter. Okay, I said my granddaughter, so you know how I should be, right? Who is less than, or when she was less than 2 years old, and we were having a dinner in a restaurant, and typically as a toddler, less than 2 years old, they would like to play. They would not like to sit on the table to enjoy their food. So as she came in, right, and we tried to sit her down in the table, she asked me to bring her to another area where the restaurants so-called display all these live seafood, meaning fish, lobsters, and all that. She wants to have a look. She wants to go there and play because she saw other kids there. Then my wife, the grandma, of course, right, told her, let's eat first before we play. And I was shocked to hear her answer. Guess what she said? She looked at the table, no food. Meaning, don't tell me to eat. I want to play first. It's not necessary to eat. And I believe this is what characterizes human intelligence against artificial intelligence, because human intelligence can link a lot of other things very quickly, not necessarily within the same space in terms of looking at food and eating, but just in terms of the fact that no food has been displayed on the table. So I believe this is where the distinction lies. And of course, in terms of computational depth and computational ability, artificial intelligence has significant depth. We don't dispute that. The way that the algorithms can be prepared, can be written, allow us to go into very deep calculations of very specific problems. So very much like the computers can play chess and outplay the chess master, right? The champion, the world champion. But in terms of breadth, perhaps it will be so-called less effective in the sense that the AI, the machines, has to be trained on a lot of data before they can actually so-called master different kind of situations or understand different kind of situations. The auto park is an example. Auto parking, as I understand it, many of the car dealers, right, or many of the car manufacturers, I should say, have actually abandoned the idea of continuing with the auto park because, right, they have found out that the consumers do not really have the confidence in the car being parked properly without any incidents. And also it is because of the insurance issues in case there is a slight dent or accidents during the course of the parking, who is going to pay for the damages? The driver can claim so-called ignorance. He's not the one parking. So the car itself, auto parking is self-parking. By itself, does it mean that the car manufacturer should pay the fine. So these are gray areas. These are gray areas that hasn't been resolved. And this is why, right, again, there is a distinction between artificial and human intelligence. So from that perspective, you can see that artificial intelligence is very specialized, whereas human intelligence is more generalized. Because artificial intelligence learns from experience. And in us human, we learn from many things in many different ways. One of which is being able to reflect, to understand what has gone wrong in our previous decisions, how we can so-called benefit from our mistakes. So this is one of the many ways we learn in terms of reflective, or reflections. And that's why we call it reflective learning. Can I have the next slide, please? So from that perspective, when it comes to human interacting with machines, as you can see, in some of these pictures that I put up here, the questions becomes, do we want us human in the driver's seat? Or do we want to relegate the responsibility now to the robots, the machines, who can do the job perhaps much better than we do, who can think faster, who can compute more complex calculations, who can examine, explore more difficult and sophisticated scenarios than what we can, and in much shorter time. So perhaps they should be in the driver's seat, in the sense that they should be in control, making the decisions. Should that be the case? I think this is one of the questions we need to ask when it comes to creating what we call a human-centric, a smarter society, centered on giving humans better enjoyment, more benefits, and helping us to live a more comfortable life. So that is the biggest question I believe we are facing at this age, when artificial intelligence becoming so clever, right? Next slide, please. So I use one example, right? This is very much in the case of what you call human. When we talk about human comfort, one of the things that we all need is what is called care, right? Medical care. Okay, so we can ask the questions: should we leave it to the machines to take care of us, as you can see on the right-hand side with this picture, right? How about a robot nurse coming in and telling us it's time for your medications, it's time that you do this, it's time that we do a check on you, it's time that we take your blood pressure or take another sample of your blood. Is it? Can we relegate that whole responsibility to them? Would it be advantageous to us? But perhaps the more important question we need to ask is, do we have the confidence in relegating that responsibility to the machine, to the machine? So I'm not saying we should or we should not. I'm opening up these questions for all of us to ponder. Next slide, please. So I believe we are all in the process of what I call, we are all in the process of searching for that optimality. In the case of surgery, as you can see here, right? We can have perhaps the participations of that very intelligent robot who can diagnose all the data that are supplied to the doctors, right? And come up with suggestions, with solutions, with ideas. But when it comes back to actually operating on the patients, should we give that to the robots who may have even more steadier hands, more skills, right, in dissections, skills in the sense that it's accurate, it's precise, and quicker in maneuvering, right, so-called the difficult terrains within the human bodies? Or should it be still leaving it back to the human hands to conduct that? So I think this is what we need to, again, grapple it. And I call this the search for optimality. Next slide, please. Why am I saying so? It is because I believe, taking the examples of the ChatGPT, that whatever we do, ultimately, the human has to be the person or the entity in control, right? Human intelligence should be the one driving artificial intelligence, just like we write all the algorithms and all those. And artificial intelligence help build what is called the machine's capabilities. While human intelligence will provide the guide, will review the so-called, right, the output created by the artificial intelligence, and we would have to see how our capability can blend into that process in order to create, right, what we call, right, an optimal situations where we can gain the trust of the recipients, the people who will be benefited by the actions, and at the same time, right, we can also harness the power of machines so that the job could be done quicker, more effective, and more efficient. So again, go back to ChatGPT. It's not like we are relegating the whole process to AI. We can ask ChatGPT to come up with a draft, for examples, when we need to write a speech, right? But we have to give very specific questions to ChatGPT so that they can write the kind of things that we want to see, right? They are much better than us in terms of doing research, doing what they call, right, internet search, doing a desk research job by scouting, surveying the internet, and trawling all the essential information relating to the subject matter, and very quickly synthesize them, compiling them, putting them together in a form that we believe, right, will have captured all the key informations. But I think we still need to go back and look at it, to ask the questions whether it makes sense, whether, right, there is such a thing as fake information being embedded, whether there's such a thing as, right, the sentence being a little disrespectful. We have to take into considerations, right, how the speech as such would project to the audience, how the audience will receive that with the kind of language being put up by ChatGPT. We have to review that over and over again, and that's where our intelligence and our capabilities have to come into the picture, to continuously modify, to rework that particular draft that the ChatGPT has produced. And this is what I believe we can so-called collaborate with machines in order to build a super smart society to enjoy the benefits of what we aspire to create in Society 5.0. Next slide, please. And I think this slide summarizes the kind of things that I'm trying to advocate in terms of creating optimality between our interactions with machines as their intelligence continue to grow, as their intelligence continue to escalate. Perhaps one day to the extent that it even supersedes us. So with that, I think This is how I would conclude my presentations. Next slide. And thank you. I'm happy to accept any questions.
Okay.
Thank you.
Thank you, Prof. Paikams. I think Professor Paikam delivers an impressive presentation. Would you please give applause for Professor Paikam? Again, Prof, thank you for presentation. I think some fruitful ideas and opinions has been delivered by Professor Paikams. He talks too much about how humans connected with machine, and then even I think Professor Paikams think for the future what will happen with the artificial intelligence and human intelligence. I think it's very interesting topics to be discussed, and uh, it isn't last presenters. We still have next presenters, but keep in mind that we are handling quite for the virtual participant and in-person participant to deliver questions. However, for virtual participant, perhaps you can chat box in the box that you have some questions, and you can list next for the question, either for Professor Roy Kans and also for Ms. Wahyu Rahmania. Okay, and for next presentations will be conducted by Ms. Andari Dwi Cahyani PhD, and I think he also remarkable speakers today because she will present an interesting topic also about an exploring Indonesian public attention towards green economy and sustainability. Okay, today, ladies and gentlemen, we are going to the next presentation, but before Mrs. Andari Dwi Cahyani present her presentations, I will also inform you a brief about our speakers today. Ms. Andari Dwi Cahyani PhD is an associate professor in informatics engineering Universitas Trunojoyo, Madura. She gained her undergraduate and master degree in Institute Teknologi 10 November, while her PhD was obtained from Newcastle University. She is also experienced as tutor and instructor for Oracle Academy and Cisco Academy. She also active in some organizations, and among others are Association of Information System, International Association of Engineering, and she has strong research records in education technology, artificial data analytics, software engineering, decision support system, information system, digital tourism, and UI design. She has also published numerous articles in national and international reputable journals. Perhaps you can see about his some article in the screens. Okay, this is some of her article, and I think we had further ado because Miss Andari Dwi Cahyani visited me. I will welcome for you to present your presentation today. Time is yours.
Thank you, Mr. Pak Triyono. Well, ladies and gentlemen, esteemed guests and fellow advocates for sustainable development, Assalamualaikum warahmatullahi wabarakatuh. It is an honor for me to be here before you today in ICST, International Conference on Engineering Society, Science and Technology, to address the topic of utmost importance and relevance in our rapidly evolving world, collaboration, and strengthening local potential for a green economy with sustainable development towards Society 5.0. Okay, so my name is Andarini, and today we will talk about exploring Indonesian public attention towards green economy and sustainability from the text mining-based analysis. Talking about green economy, this concept refers to an economic system that aims to promote sustainable development by integrating environmental considerations into decision-making process. So the idea of green economy has become a top goal for many governments of the past 10 years. If these companies can make their economies more sustainable, they will be ready to face the biggest problems of the 21st century, such as climate change, population growth, and unstable economies. So, people, planet, and profit. This is a concept often referred to as the purple line of green economy. So, it represents a framework for sustainable business practices. This approach recognizes the business should not only focus on profit or financial performance, but also on social responsibility, people, and also planet, the environmental stewardship. Business success depends on profit, yes, but this concept, this strategy, emphasizes the social and also the environmental responsibility. In an era where our planet faces unpredictable challenges, the adoption of green economy principle is not just a choice, but it is a necessity for the well-being of our environment, society, and future generations. The ideas we'll be talking about today are the foundation of the green economy principles, which are resource efficiency, renewable energy, biodiversity conservation, and circular economy. So, resource efficiency is not just about getting more than less. Yeah, so it is a commitment to make best use of our resources, cutting down on waste, and also making a little impact or harmful impact on the environment as possible. We can use resource economy as well without hurting the environment if we use new technologies and also follow the environmentally friendly method. Talking about renewable energy, moving toward clean energy is not just change or transition, but it's a revolution. Our support of solar, wind, or hydro, and other renewable energy, social education to a greener future. We minimize our dependence on finite fossil fuels and help future generations by harnessing the power of the sun, wind, and water. So renewable energy is what keeps the green economy going and help us make progress while protecting the environment. About the biodiversity conservation, well, every living thing in Earth is an important part of the planet. It is not a choice to protect the biodiversity because the biodiversity ensures our food security and also provides many medicines that came from the natural and also builds adaptive ecosystem. So we can protect the variety of life on Earth by keeping habitats, ecosystems, and encouraging healthy livelihoods. Talking about circular economy, so the linear take, make, and dispose is no longer possible. It's unsustainable. The circular economy is a big change because it turns trash waste into resource and also make the principle that we make goods or stuff that lasts longer. So we reduce waste by reusing, recycling, and designing our system. This also saves energy and raw materials. So the circular economy is a plan for making production and usage more environmentally friendly and sustainable. It creates a cycle of growth that is good for both the economy and the environment. insight. So it is about the fascinating world of text mining. So text mining is the process of getting useful information from written text in everyday language. The text that we send and receive in text messages, emails, paper, social media, or any files is all written in common language text or is unstructured form. So the text mining is mostly used to find patterns or ideas that are useful in large amounts of textual data. Text mining uses various AI, artificial intelligence technologies, to automatically process data and find useful insight, which help business make decisions based on data. So this data then is then turned into more structured file. So for further analysis or even presented in the visualization to make to help human to make a better decision. Okay, now let's talk about the transformative power of text mining. It not only unlocks the potential of massive amount of textual data, but also shapes the landscape of risk management, fraud detection, business intelligence, social media analysis, and also customer care service, as you can see in the diagram. So the benefits of text mining for risk management are huge. By analyzing text data from a variety of sources, including financial reports, market analysis, news articles, the company or business can get unique insight into potential risks. So, for example, sentiment analysis can be used to assess or evaluate public sentiment towards a company or industry or branding or a new launch product. So it can provide early warning and proactive approach for risk mitigation. And talking about the fraud detection, text mining also can help us fight scams in a big way. So advanced algorithm can find trends that point to a fraud by looking through huge data set that includes emails, transaction, interaction with customer. So the unstructured text analysis helps us to identify red flags and also stay ahead from the scammers. Next, about the business intelligence. Yeah. So text mining also support business intelligence by revealing hidden insight in textual data. The companies can figure out what their customer want, what the trends are in their business, and how people feel about new markets, about new products by using sentiment analysis. This topic, my students do a lot of research about this sentiment analysis. And we can also use topic modeling and also pattern recognition. So this rich information can aid the decision making and help the business to stay competitive in the dynamic markets. Talking about the social media analysis, so it is important to know what people are talking about in online discussion or forum. And text mining lets us look at a lot of social media material at once. Business may improve brand reputation, product innovation, and also customer engagement by studying more on sentiment analysis or using other text mining method. And last, the text mining changes the way customer service works by automating and improving conversation. So, natural language processing, it's part of text mining, enables chatbot to understand customers' question, feelings, and taste, allowing them to provide personalized and effective support. So, as mentioned by Prof. Boy Kim, answer the user question. Not only the chatbot can make the customer happier, but it also lets you let us spot and fix possible problems before they go worse. So in conclusion, text mining has many benefits that give business an edge in a world full of information. As we embrace this game-changing technology, let's picture a world where data is not just a problem, but is a strategical asset, a tool that helps us to manage risks, find fraud, gather intelligence, understand how people interact with each other, and provide excellent customer service. Okay, now I'll be talking about the fascinating research problems that are very important to the field of sustainability and natural language processing. First is how to find the best parameter for topic modeling using the LSA method. So, finding suitable topic modeling parameter is essential for gaining insight from large data set. In particular, latent semantic analysis in LSA can reveal latent structures in textual data. So, this study question, this research question leads us to learn more about text mining method. We are evaluating carefully experiment and validate parameter values, find the most interpretable and contextually relevant fields. The goal of this exploration is to fill the language with better details. And the second research question, what are the topic models from Twitter data using the Indonesian language called economy and sustainability? So I did my discussion in Indonesian language. The tweets from Indonesian people in Indonesian language. Our second research question asks to Twitter where a real-time conversation happens. So when we talk about the green economy and sustainability in online forums such as Twitter, the Indonesian language comes up in a lot of conversations. So we examine Indonesian tweets to answer this question. The purpose is to find subjects and understand of users' opinion, issues, and their aspirations. This research gives a unique glimpse into a green economy discussion and reveals a society passionate about green economy and sustainability. We can find significant insight and hidden patterns in the immensity of unstructured information using text mining algorithm. First, we start with the information extraction, which organizes text into organized knowledge. Imagine being able to identify entities, pattern, relationship between words. Information extraction turns the world of language, which seems to be mapped into organized, structured document of textual data. As we go deeper, we meet information like before. So it is works like sophisticated search engine. Information retrieval involves discovering relevant points or data from a large collection to answer user queries. This strategy helps us find what we need in single data. And third, the text mining technique, also called natural language processing or NLP, which connects human language to machine understanding. NLP lets computer understand, interpret, and respond to human language. And NLP also unlocks the deeper meaning of words through sentiment analysis and part of this thinking. The next method is classification. This technique helps us organize and understand the rising cost of explored data and finally is about clustering, which relates to text, reviews, data patterns, and correlation. It is an exploration of knowledge that uncovers hidden interconnections between words. So in a simple term, clustering is used in topic modeling to group comparable items or documents. Imagine a large library of informational literature. Librarians magically cluster related book on the shelves. So when the user need information about certain topics, they know which shelf they have to visit. Digital clustering works similarly. So it groups comparable documents by finding patterns and relationship in big textual data. This helps us find data-driven trend, topics, and discussion faster. Okay, picture this. You have massive collection of documents, and you want to find out what they are really about. So the LSA steps like a linguistic detective, analyzing the words and pattern to reveal the underlying themes. LSA doesn't just look at words, it looks at how words dance together. It spots the connection and similarities. It's like finding the melody of the symphony of the words. Okay. Talking about the research method. Yeah. Okay, now Twitter has recently rebranded itself and is now officially known as X. It's one of the most influential social media networks with approximately of 350 million active users in 2023. That's why we decided to use data from Twitter since it has massive document of text. Data was captured on 7th of July 2023 and we use AP5 to scrape the data. And the keywords that we use is green economy and sustainability. This figure shows an overview of research flow. The model development process begins with collecting dataset in an online portal, and then the text processing is carried out, which is useful for making the data structured and ready to be processed. After the text processing, pre-processing is done, the next process is LSA model, making the LSA model. Okay, thank you. And the last process is evaluation using topic coherence to get the best number of topics and evaluation of the LSA model that has been built. Okay, next. So this is the data pre-processing method. We have case folding to make the convert all text to lowercase to ensure the uniformity, and then we have a data cleaning to remove unnecessary punctuation mark, unnecessary spaces, symbols, special characters, HTML tags, URL, because we want to focus on the textual content. And we also have stop removal. This works to remove the connection words that is not necessarily needs to understand the sentence, and then stemming and also tokenizing. So this is how we do it. We build the term document matrix, or TF-ADF. It's a term frequency and inverse document frequency using the kind of formula. It is on the screen. Next. We can see that the document matrix is very sparse and large. That's why we use SPD, single vector decomposition. We decompose the matrix into 3 different matrices, matrix U, S, and V. And next. Here we measure the coherence of the clustering. This is the principle. The right side on the screen shows the good clustering, since it has a low inter-cluster distance and high inter-cluster distance. low intra-cluster distance, sorry, and high inter-cluster distance. So the distance between the cluster is high. So it means that this side and the other side represent the bad clustering. Okay, now we move to the result. Before this, yeah, so this is the result about the visualization. As we can see in the visualization, the prominent terms that comes up, such as green economy, sustainable, renewable, etc. This visualization can help us to find the most prominent topic that comes from our data.
I think because of the time, can you make it faster?
Okay. Yes, thank you. And then, next slide. And then this our coherence score. So we have for testing scenario to find the best has coherence, and as we can see, there are 6 topics with the standing and use of removal, and then use this parameter to define topic model. Next. Yeah, so this is topic model, and then what we do is to interpret this topic model into a large topic, a greater topic. So this is the analysis and interpretation of the 6 topics that found in our study. Yes. So the conclusion is to answer this question, we can use this coherence score and NPMI, so like cluster parameter, topic model, and topic model clusters. Topic model clusters found in our research is sustainability, green initiatives, and also economics. So this, thank you for your attention.
Okay, thank you, Mrs. Andarini Dwi Cahyani PhD, for her presentation. I think she's also delivered impressive and interesting presentations. Give applause for her presentations. Well, I think three presenters have presented their presentation for us, and now the session is about question and answer. I invite kindly for the participants in person here or virtually to send questions. I will define this part into 2 terms. The term I will give chance 3 questions, and second terms I will give chance 3 questions. Okay, perhaps for the participant, you can raise your hands by mentioning your names and your affiliations. And for virtual participants, you can also your questions in the chat box. Okay, if you have any questions, please, for the questions, you can address the question to who, or Ms. Wahyu Ramaigar, or Professor Baikhands, or perhaps Ms. Andari. Please raise your hands, or perhaps you can send your questions in the chat box. Okay, chat box. Sorry, I cannot find chat box. You can help out. Okay. We have 3 questions, I think. The first one, perhaps it is addressed to but I tried to read this question first. What are the main challenges faced in implementing artificial intelligence technology in the training of medical imaging? And the second question is, how can ChatGPT contribute to the evolution of industry 5.0 and humans-machine collaboration? And then the last question is, how can latent semantics analysis be applied in understanding context or hidden meaning within long and complex texts? I think that the three presenters are invited to answer the questions. Uh, Perhaps I will invite Ms. Wahyu Rahmaida to give response on the questions.
Uh, Sorry, my name Wahyu Rahmaniar.
Sorry, Ms. Wahyu Rahmaida. Sorry.
Is it the question is how challenging to apply AI on medical image?
Yes.
Actually, in medical image first is difficult to find the dataset because it's very private. Like a doctor and hospital cannot share it publicly. So maybe we can only find hundreds or maybe less than a hundreds image. So which actually in AI we need more than 1,000 images to get the best results. So that's the first challenge. Another is in medical image we can see either X-ray, CT, or MRI. Those are in the grayscale, and then between the bone and then our and another area is almost similar because the then if we want to find the fracture or tumor or cancer, so to get the precise area is quite difficult because it looks almost the same with another area in the image. Yeah, that's the second challenge. And the third challenge, like currently, like in my lab, it's biomedical meds, and we still try to improve and improve. Like currently, this kind of improvement may be still difficult to apply it directly to the hospital because, like, maybe we have some. Yeah, the first is data set. Maybe we have a data set, publicly data set, but we try our network and the result is good, but maybe when we try to another hospital, like when they capture the X-ray or the CT scan or MRI, may be a bit difficult with what we get from our data set. So there's another challenge that maybe our algorithm will be not as accurate as the application in our data set. So this, I think that's all.
Okay, thank you, Ms. Wahyu. I think she gives us an elaborative answer. I think, and I do hope the question answered well for you and satisfied for you. And okay, for next questions, perhaps it is addressed to Professor Boykans. Should I repeat the questions? How can ChatGPT contribute to the evolution of Industry 5.0 and human-machine collaboration? Okay, Professor Boykam, would you please answer the questions?
I am not an expert in programming, neither am I an expert in ChatGPT, but I'm a user of ChatGPT, and also from what I understand, how ChatGPT learn is that they crawl all the information from the internet on the specific topic, on the questions that you pose, and then they spit out the answers based on what they have gathered. Right. So in other words, the most important thing about harnessing the ability of ChatGPT to give us advice on specific topics is to be able to frame our questions very, very precisely in the way that that a person will understand it. So ChatGPT can understand that questions and can pick up the relevant pieces of information to provide what is called an integrated and synthesized answer. And I think that's the way how ChatGPT works from my understanding. Now we have to bear in mind that at this stage, from what I understand, is that ChatGPT stores all the informations that are available in the internet within so-called its disposal, whoever is the host of the internet, of the ChatGPT. So there could be informations that are so-called fake informations, as we call them, or misinformation. We have to be very careful in that. It's like what kind of data we feed to ChatGPT to allow ChatGPT to provide us what is called an integrated and synthesized answers that's relevant to the questions. So we have to put ChatGPT within the so-called the realm of data that perhaps will provide the best sort of answer. We even will not be able to dump through all those very quickly, right, and remember everything. But ChatGPT can and can do it in a way that pick up only the most cogent, relevant part that provides the answers that someone can understand. This is how I believe ChatGPT works. So I hope I answer that question, and I hope I understand what you mean when you pose that question.
Thank you, Professor Fray. I think Professor Fray has delivered good answer and also elaborate answer. And I hope also that the question, the answers was right for someone who delivered these questions from anonymous ones. And next question, I think is addressed to Andarini, is from to Anna also, that the question is, how can Latin semantics analysis be applied in understanding context or hidden meaning within the long and complex text? Okay, is the right one?
Thank you for the question. That's a nice question.
It's about how Latin semantic analysis can be applied in understanding the context of hidden meaning. So perhaps the meaning is how we use these models to analyze hidden meanings within long and complex texts.
So this LSA, Latin semantic analysis, is you use this method to cluster similar documents and then to interpret the context of the hidden meaning. We use human intelligence for that. So this is artificial intelligence on complex document to sort the document that has similes and then to interpret that as the intelligence works. So it is not the LSS. LSS only complex document mentioned as similes, and then we can conclude from the visualization on even the prominent terms that often came up in the LSS.
Okay, thank you Andarini for the answering some questions. Okay, we still open just 1 second from I think 3 questions for audience, 1 participant to deliver questions, and particularly I think it's for in-person participant who can deliver the questions. Okay, is there any questions? Raise your hand please if you have any questions. Okay, perhaps for myself, is it possible to ask for some questions? Okay, first, I'm interested for all to present when they are presenting the methodology, and I think it's very insightful. First, I'm interested also with the from Professor Boy Camps, and I think it's very interesting when he tried to combine machine and human. Professor, I have a question. This one, what will be major opportunity and major challenge for us in the future? Are you still with us, Professor?
Yes, I am. Can you repeat your question? Sorry.
Yes, I'm interested in the topics we given to differ how machine and human interconnect with each other. And my question is, what will be the major opportunity and major challenge for us as human? Because before you explain how artificial intelligence works and how human intelligence works, my question is, what will be a major opportunity and major challenge for us as human? Thank you, Professor.
A very quick question. Uh, well, I think we can look at a lot of areas. In fact, that human and machines can interact, and the key is to understand where human stands and where machine stands. So in circumstances, right? Again, coming back to in circumstances where the situations is pretty well defined, and the machines has been to learn the situations or learn the context surrounding the situations very well, and that context is relatively static, and the decision is very much like following a rigid protocol, then artificial intelligence will be best poised to do the job. That's what I believe. But when the circumstances surrounding the situations are relatively fluid and it can change, meaning highly dynamic, then a routine protocol as such that has been designed and suits well one particular context or situations may not work in another context or situations, right? And that context could be cultural differences, could be locational differences, could be anything for that matter, right? Then the human intelligence has to come into play. This is, I believe, that's where human intelligence will have a much important role than artificial intelligence. This is not to say that artificial intelligence or AI would not play any role in that kind of circumstances. AI can still provide suggestions relating to similar type of circumstances and how some of those situations have been tackled or how solutions have been found, but then that would have to be examined by humans who will see whether that kind of solutions fit the circumstances. And I think that is where human being can again play a part here. So in other words, what I believe, right, in situations that are relatively uncertain, complex, and dynamic, humans should be the final arbitrator. Is it? And lastly, I think there's also the question of who are the beneficiaries of those actions. Whether the beneficiaries can trust the answers or the solutions provided by the machines. Is it? Even though machines, like I said earlier, might be best so-called positioned to provide the solutions or to execute the work. But then the recipients, the beneficiaries of that task will still have to have the trust that the machines provides. So the example would be like the auto parking, is it? Right? I believe that a lot of work, from what I understand, right, has been done in terms of how to train the car to park in many different kind of circumstances, different kind of so-called terrain configurations, parking configurations, and whatnot. And yet, the person who is in the car, the driver, leaving the whole job to the AI, to the auto park to do it, has to have full trust in the computer to say that I don't need to worry. It will be safe and it will be incident-free. There will be no issue with insurance. There will be no issues with my personal safety. I think that is also a very vital part, because lack of that, then ultimately, right, human may intervene even though the machine can do the job very well, and that can so-called, right, mess up the process. And this is what I think there's still a lot of work in those areas we have to do, right? Because this is not just between the human actor and the machine as actor. This is also a question of the recipient, the person who's going to benefit from the actions, right? Either conducted by the machines or conducted by the human. I hope I answer your questions.
Thank you very much, Professor Joy Camps. I think you have opened my mind about artificial intelligence and human intelligence and how they are interconnected. Thank you very much for the answer, Professor Boy Camp.
Thank you.
Okay. Is there any still questions? Okay. I think because of time also, and we come to the last session of this panel session. Before we come to the end, I think I want to sum up about this panel session that engineering, science, and technology are essential matters that interconnect with humans. And today, we got many perspectives of this science, technology, and engineering that helps human beings. This belongs to what Ms. Wahyu stated before about artificial intelligence, and also the explanation from Professor Peikans about how machine and human interconnected, and also how Bu Anda Rini explained us that when we do something, engineering also help us based on text mining. And then the last one, I think, is our excitement to have benefits from science, technology, and also engineering for human lives. Before I close this session, I would like say many thanks for the three presenters for great presentation, and also for all the participants who come in person or who come virtually. Okay, keep applause for the presenter and also participant for active participation. I think that's all. Thank you very much, Bu Wahyu. Thank you very much, Professor Poikens, and also Bu Andarani for your time and fruitful idea of your presentation. Thank you. I think it's enough. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, ladies
Thank you.
and gentlemen, thank you for today for speaker. Thank you for this fun event. And then give applause for today. Thank you very much and see you next time. Bapak Ibu yang saya hormati, untuk selanjutnya yaitu acara makan siang ya Bu ya. Makan siang di lantai 6 untuk yang sholat di lantai 8. Terima kasih. Untuk makan siangnya sampai pukul 3. Sesi foto mungkin? Oke. Peserta, mungkin ada yang foto bersama atau mungkin dari berdiri.
So sorry to announce it, perhaps because we have come to the end of this session. For virtual participant, you might leave also the rooms, and in-person participant, we also leave the room. But before for the virtual participant, for only in-person participant, we have photo session, isn't it? Yeah. Thank you. So again, for the virtual participant, you might leave the room. Thank you for joining us.